Hey everybody, I'm making this video for Lucy. She asked about setting up number 64. I'm just going to share this with the whole class in case anyone else has questions as they are working on their classwork. So we have an airplane. Let's say here's our airplane. It's traveling 400 miles per hour and it's cruising at an altitude of 6.6 miles. So the airplane is currently 6.6 miles above the ground. It then begins its descent, so the plane is now going to be moving downward, and it's descending. The angle of descent is 2 degrees from the horizontal. So this 2 degrees from the horizontal tells me, if I put a horizontal in from the plane, this angle right here is 2 degrees. They're now asking us to determine the new altitude after 15 minutes. So I'm going to just continue to scroll down, or to fly down the plane. Eventually, after 15 minutes, the plane's going to be, let's say, maybe right here. So what we're interested in is what is the new height of the plane now. I will call this x. So some things that we do know. We definitely know that this angle is 88 degrees. This is a right triangle. So this angle down here is also 2 degrees. Our goal is to work within that smaller triangle. So what we're going to do is we're going to use the information about how fast the train was traveling to determine what this length is right here. So generally speaking, distance is equal to speed times time. We know the speed of the plane was 400 miles per hour. And the time is 15 minutes. 15 minutes in hours is 0.25. It's a fourth of an hour. So make sure you change that unit. So I'll go ahead and multiply these. My hour unit cancels out, and I know that the distance that the plane traveled is 100 miles, which is this blue distance right there. So we have a piece of the hypotenuse for the entire triangle. Now let's see what else we can figure out. Because in order to solve for x, we're going to need at least one other side from the smaller triangle. So what I mean by that is that in order to solve for x, we're either going to need that distance there, or we're going to need this distance here. Either one. Since we already have a piece of the hypotenuse, let's go ahead and find that blue distance. So what I want to know is what is the entire hypotenuse for the big triangle? Well, in the big triangle, 88 degrees is right there. 6.6 is adjacent to it. Using TOA, I know that cosine of 88 degrees is equal to adjacent, which is 6.6 over hypotenuse. I'm just going to call the hypotenuse, we'll just call it HYP for now. If you solve this, you'll see that the hypotenuse is equal to 6.6 over cosine of 88 degrees. And I'm not going to put that in the calculator just yet because I don't want to get any rounding errors. So I know the entire hypotenuse, is a better way to put that, is equal to 6.6 divided by cosine of 88. Which then means that this blue piece right here must be the entire hypotenuse, which is 6.6 divided by cosine of 88 degrees, minus the 100 miles that the plane had traveled in its 15 minutes on its descent. So now that I know that, I will put this in the calculator just because I don't want it to look messy. And that gives me that blue distance of 89.1144751. And I'm just going to leave that all those decimal places because that's not our final answer. But now we can work within that smaller triangle. We can look at the 2 degrees. We can see that we're interested in finding the opposite of it, and we have the hypotenuse of the smaller triangle. So now we're going to go and use sine. It tells us that sine from sine of 2 degrees is equal to the opposite side of x over the hypotenuse of 89.1144751. And then we can take this equation and finish solving for x. I know that was a lot, and then especially because we didn't look at a word problem like this in class together, which is another reason why I'm glad Lucy asked this question and I was able to make this video. But if you have any questions about this, feel free to shoot me an email. We'll also have time to talk about this in class together next week.